So in this video, we are going to look at molar mass and a unit called the mole, which we use frequently in chemistry. The mole is the metric or SI unit for the amount of a substance, and it's often abbreviated as MOL. So in our problems, you can write mole as MOLE or MOL, but the mole is a unit, kind of like a dozen. So it describes a certain number of pieces. I can go into a bakery and I can say I want a dozen donuts, and they know I want 12 donuts. I can walk into a chemistry lab and say I want a mole of copper, and I know that that's a certain amount of copper. And that amount is a number called Avogadro's number, which is 6.02 times 10 to the 23rd. That's the number of particles in exactly 1 mole of a pure substance. So like I just said, if I went to the bakery and said I want a dozen donuts, I would get 12 donuts. If I walked into a chemistry lab and said I want a mole of copper, I would get 6.02 times 10 to the 23rd atoms of copper. Those particles that number represents can be atoms, ions, molecules, or formula units. So you should recognize those 4 terms and know that whenever we see those terms, we're going to be using Avogadro's number, or 6.02 times 10 to the 23rd. Now, when we're relating the amount of a substance to its mass, we're going to use something called molar mass. This is the mass of 1 mole of a pure substance, and the units are grams per mole, and it's found by adding up all the atomic masses. So it's pretty simple when you're dealing with just an element. So we see here in our picture we have the element carbon, and the atomic mass is 12.011 AMU, and the molar mass is 12.011 grams per mole. So when we're dealing with a single element, the molar mass is the same as the atomic mass. But how do we find the molar mass when we're dealing with a compound? What we're going to do is we're going to add up the mass of each atom that makes up the compound. So here are 2 graphics, and they both show water. So in this one, water is 1 oxygen combined with 2 hydrogens. So we have our 1 oxygen. We find the molar mass of oxygen on the periodic table. An atom of oxygen has a mass of 15.9994 grams per mole. We find the mass of the first hydrogen. On the periodic table, hydrogen has a mass of 1.00794, and then we add the mass of the second hydrogen. So we add another 1.00794, and when we take the sum of those 3 numbers, we get 18.0153. Another way of looking at it is when we look at the formula H2O, this subscript of 2 beside hydrogen tells me that I have 2 atoms of hydrogen. So I take my 2 times the mass of hydrogen, which is 1.008. Again, if I look at the formula, there's no subscript beside oxygen, so that tells me I only have 1 atom of oxygen. So I've got 1 times the mass of oxygen, which is 16.00. And when I add those numbers together, I get 18.02 grams per mole. So generally, we recognize that the molar mass of water is 18.0 grams per mole. Here's another example. If I'm looking at glucose, which is C6H12O6, my formula tells me that I have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So I take my 6 atoms of carbon and I multiply it by the mass of each carbon, which is 12.0, and I get a total mass for carbon of 72 grams. I take my 12 atoms of hydrogen and I multiply it by the mass of each hydrogen, which is 1.0, so 12 times 1 gives me 12 grams total for hydrogen. And then I take my 6 atoms of oxygen and I multiply that by the mass of each oxygen, which is 16.0. 6 times 16 gives me 96 grams of oxygen. Next I add my 72 plus 12 plus 96, and I get a total of 180 grams for the molar mass for glucose, or C6H12O6. So let's do a sample problem together. In this problem we have calcium phosphate. Okay, so we're given the formula Ca3PO42. What I want to do is start breaking down what elements do I have in my compound. So when I first start, I notice I have calcium, and my subscript here tells me that I have 3 atoms of calcium. So I'm going to take my 3 atoms of calcium times the atomic mass of calcium from the periodic table, which is 40.1. Next, I take a look at my next element, which is phosphorus. Now here you notice the parentheses, and there's a 2 outside the parentheses. So in chemistry, this is very similar to math. My 2 distributes into the parentheses. So I actually have 2 atoms of phosphorus, and I multiply that by the atomic mass of phosphorus, which is 31. And I do the same thing for my oxygen. In the parentheses, I have O4. The 2 outside the parentheses distributes in, so I have 8 atoms of oxygen, and I multiply that by the atomic mass of each oxygen, which is 16.0. So 3 times 40.1 gives me a total of 120.3. 2 times 31 gives me a total of 62, and 8 times 16 gives me a total of 128. My next step is to add all of these numbers together. So 120.3 plus 62 plus 128 gives me a total of 310.3 grams per mole for calcium phosphate. So again, what I'm doing is I'm looking at how many atoms of each element are present in the compound, and then I'm multiplying that number of atoms by the atomic mass. And my final step is to add up all of my answers for the elements in that compound, and that gives me my molar mass. Try these practice problems at the end of your notes. Find the molar mass of each substance: magnesium, iron 3 oxide, and calcium hydroxide. Write any questions you have on the side of your notes, and make sure you show your notes and these practice problems to Mrs. Benke in class.